Okay, so this is CSC200, the game programming DLE flippy thingy class. I am Dr. Littman. You can call me Dr. Littman, Yo Fatty, Mike, Hey You, any of those work. You may have seen my car around campus. It's the one that says Awesome Fat on it. In a former life, I was a professional eater. 15 years ago, I was the #1 ranked distance eater in the world. I hold the world record in beef at 17 pounds, 2.5 ounces, in 41 minutes. So, Yo Fatty would be appropriate. So I retired from that, but if you watch TV, maybe you've seen me on Travel Channel or something like that, eating ridiculous amounts of food in too short a period of time. Oh, and today is my birthday.
Happy birthday.
I don't get a song.
You probably don't want
get a musician in there. All right. So, let's see. Let's look at the syllabus first. Oh, and I already wrote a homework assignment for you. It's going to be hilarious. I made it so hard, too. I figured you just got back from Christmas break. You kind of need a warm-up, right? Okay. So this is the class, blah, blah, blah. This is me. This goes to my cell phone. Feel free to text me at this number. You can call, but I probably won't answer. Not you. I don't even answer the phone for my mom. She has to text me first and set up a phone call. So anyways, texting me is just fine. You could text me any hour of the day. I'm usually in bed by 1 a.m. or so, but if it wakes me up, I won't be that upset. This is when the class meets. Here's my email address. Best way to get a hold of me is text or email. If you don't hear back within about 2 hours, send it again, because I get a lot of texts and a lot of emails, and chances are it's fallen off the radar. Blah, blah, blah. The textbook for this class is that stupid book that Dr. Locklear has you get in the 150 class. I'm not going to use it. So just officially, that's the textbook. It's not a bad book. I just won't use it because I'm kind of lazy. Objectives, blah, blah, blah. All computer programming languages are created equal. That's a truth. Next thing you'll learn in here is that computer programming is not computer science. Rather, is the tool we use to solve problems in an applied way, much like a hammer is to a carpenter. You'll learn that computer programming can be fun. Might take some time. You'll actually probably find it fun in here. And then next class, when we start dealing with real syntax, you'll hate it. And then you'll like it again. So we lull you into a sense of self-confidence in this class because everything's drag and drop. It's like, oh, look, Mario's dancing around the screen. The next semester, it's like the worst parts of the Bible. Okay. And appreciate the effect of a Christian worldview on the discipline of computer science and gain an understanding of the responsibilities and ethical issues a Christian professional will face in a computerized society. That was a mouthful. Yeah, so I tried to incorporate a Christian worldview into the classroom. I kind of suck at it, but I make lots of jokes. So you should laugh a lot, and I think Jesus probably laughs. So I'm really hoping God has a good sense of humor. All right, so there's topics, blah, blah, blah. We'll just kind of start going through some stuff. Grading in the class. Homework assignments will represent 45% of your grade. Quizzes, 15% of your grade. These are all pop quizzes. I'll just show up and decide, hey, we're going to have a quiz. Usually I do this if I feel like I want to give a quiz, but more often I'll do this if like people stop showing up to class, and it's a good way of taking attendance because I'm not going to sit here and call out 4,000 people's names. So in any case, you're all adults. If you have something better to do than show up to class, doesn't bother me, but know that you're probably going to miss a quiz. Okay? Midterm, 20% of your grade. Final, 20% of your grade. Grading scale, the normal DLE flippy. So, and A is 92 and higher. 90, 91 is A minus. So on and so forth. So the bottom 2% of every 10 is a minus. Top 2% is a plus. After that, it's a solid grade. All right, questions about any of that crap? Okay. So, let's see, what am I doing? Let's go here. See, I want to get rid of this. Aha! Magical. All right, before we go, does anybody have any good stories of anything that funny that happened over Christmas break? I mean, I don't want to hear like, oh, I went skiing and had a lot of fun. I want to hear like, I went skiing and somebody snapped their leg in half. I don't want to know they died. I just want to know they got hurt real bad and cried. Nobody has that? There you go, like crappy breaks. Okay, so this is CSC200. Kind of the goal of this class is, well, let me ask this question. How many of you have ever written a computer program before? Okay, what languages?
Java.
Java? Okay, go ahead.
C#, C++, and Visual Basic.
Okay. Anything else that cover everybody else has done? Okay, what is a computer program? If you had to give me a definition of what it means to be a programmer, what would you say? There's got crickets. Like half the class just rose their hands and says, oh yeah, I've written a program. And you start throwing out these languages and nobody can say what it is?
It would be to write algorithms for the computer to understand.
Okay, what's an algorithm?
It's a set of instructions, very detailed instructions.
Okay, so computer programming is our language to tell the computer what to do. So just like I'm speaking English to you, conveying information, a programming language is our means to tell a computer what to do. Okay? This isn't the kind of slide I want. I want one of the bullet point slides. Aha! All right, so I always amaze myself. Every single time I get in front of these computers, they do something new each time. All right, so programming is using a language. Oh, and by the way, I record every one of my lectures, screen capture and voice. I put it up on YouTube, and I give you a link to it on Angel. So if any of you are looking for that, now I watch Doctor Who at night before I go to bed, but you could watch Dr. Lippman and lull yourself to sleep with my calming voice. Okay, so using a language to tell a computer what to do. Okay, so what's a language? Well, what are the normal languages we know about? Are like English and French and Spanish. And how many of you speak more than one language? What languages do we speak? German?
German.
Yeah, you. Huh?
Vietnamese.
Vietnamese? I was hoping he was going to say like French or Spanish. I don't want to stereotype, but my guess is it would have been Vietnamese. Okay. Now, human beings, when we talk to each other with natural languages, if somebody gives you kind of, let's say you're having a party at your house tonight, and you're saying, you're inviting your best buddy Mike over there. I know many of you just met me, but we're going to be buds. So anyway, says, yeah, just head down Main Street. It's like the third or fourth light. There'll be a gas station on the left. Just turn left there. And I'm like the fifth house on the right. You'll see a pink Pinto in the driveway or something like that. So if you give somebody directions to your party like that, will a human being more than likely be able to fill in the blanks and get there? Yeah, we'll be able to hunt and peck our way there, right? Because humans are smart. I know some of you think you're idiots. Okay? Some of you are. Okay, but you're far smarter than you probably think you are. Human beings are great problem solvers. We're so good that we forget how we solve problems. We're going to see that here in a few minutes. So a human being is so smart, we're able to fill in the blanks without even really thinking about it, right? Computers are dumb. How many of you, I always ask this every semester and I always date myself. How many of you have seen the movie, What About Bob? 3 people, 3.5 people. I saw you, he was the half. So, how many of you heard of Bill Murray? One of the original Ghostbusters, right? Mm-hmm. So Bill Murray was in this movie called What About Bob? And I always compare What About Bob to programming. You should go and watch this movie if you get a chance. It's a really funny movie. It's got famous actors in it. Richard Dreyfuss is in it. And in any case, Bob, played by Bill Murray, has some severe social anxiety issues. Okay? Can't really function in society. He goes and sees his shrink, played by Richard Dreyfuss, who's basically a jerk. Okay, this guy's just in it for the money, blah, blah, blah. Wrote a book called Baby Steps. Well, anyways, Dreyfuss is getting ready to go on vacation. And Bob sees him right before vacation, and he gives Bob the book and says, you know, while I'm gone, read this book, and, you know, you're going to baby step your way to better whatever. And, oh, Bob's all about this. He's baby stepping to the elevator, but, you know, he no longer has to, like, use a Kleenex to open every single door. And so then hilarity goes, and he starts stalking. He follows his shrink on vacation and stalks him and all that. It gets pretty funny. But the idea is that computer programming is very much like that book, Baby Steps. We have to slow our mind down. We have to think about how we're solving problems. We have to go so slowly that we make sure we don't miss any of the individual details. For a human being, if I say it's the 3rd or 4th light, you'll see a gas station to the left, that's okay. That's not going to cut it for a computer. Remember, computers are dumb. People are smart. Some of you are smart. Which means some of you are people. It's a logic thing. How many of you have had any of the logic classes with Manoj? Yeah, I love Manoj. Ask him about queuing up. He's a British guy. You ever met him? Yeah. Oh, you'll like Manoj. He's a good guy. Yeah, but he's very British. So yeah, but he's funny. He tells like the dry British jokes and stuff. Everything's about getting in the queue. Because that's the Brits. They get in the queue to line up. They're professional liner-uppers. Man, see, this is what I hate about Facebook. When it's your birthday, everybody's like just wishing you happy birthday, and then you have to go and unmark all your... Can you people just leave me alone? All right. So, languages come in a couple different formats. We have natural language. Natural languages. This is like English and French. Here, I'll put German in there. That's a language, right?
Some would say.
Blah, 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 blah. Okay. Well, then we have programming languages. We also have something called protocols. So let's take this a step further. For us computer geeks out there, we've heard of, how many of you have heard of the word protocol before? All right, what is a protocol? If you had to give a concise definition for a protocol. I'm a big fan in computer science of, we use a lot of words that mean simple things but sound hard. And then geeks just throw around these words like it's just common sense. But then I like calling them on it because sometimes they don't even know the words they're using and it's funny. I do that at Best Buy all the time. It's a hobby. Sometimes my wife's at Kohl's shopping. I go next door to Best Buy and just go into the computer section, act like an idiot, and ask them how many gigaflops a hard drive is or something like that. And they give you a number. Well, you know, this one's going to be about 7.6 gigaflops, but, you know, this one's going to have less heat. Protocols. What are protocols? Go ahead.
Rules.
Give me an example of a protocol. Let's start with that. What?
the correct way to do something.
What's that example?
Like
Give me like a named protocol, an example of a protocol. What?
HTTP.
HTTP. Okay. What's the HTTP protocol?
The web page. Protocol.
Okay. It's Hypertext Transport Protocol, and it is the language by which web pages are sent over the internet. Okay. Somewhere on the internet there is a web server, and then you have your web browser, and your web browser connects to that web server and speaks a language that is the HTTP protocol. And that's the way that web page and the images that are on the pages and the hyperlinks and all that stuff gets transmitted. Okay? So protocols would be a type of language, kind of a simplified language that two similar parties use to get information back and forth. Okay? So they would be much simpler than a natural language. Would be much more similar to programming languages in that they must be very discrete. There can't be any ambiguity in protocols or programming languages. All right. For this class, we're mostly interested in programming languages. Okay. So, some examples of programming languages that we may have heard of. What are languages we've heard of? A couple people said I heard Java. I heard Visual Basic. I heard C#. What else? What other languages?
Python.
Python. Ooh. What else?
C++.
C++. See, now it's like Jeopardy. You know, name the top 15 languages. Any more? Let's see. What?
PHP.
PHP. Okay.
JavaScript.
JavaScript. Oh, yeah, we're picking up steam. I'll eventually stop us when we get too big of a gap, but let's just see how many we can spit out. CSS. Okay. Ruby.
Perl.
Ooh, it's an old one. HTML. Oh, yeah, we should give it proper all caps treatment. MySQL, no. MySQL is a database management system. SQL would be a programming language, structured query language. So MySQL is like Oracle, is like DB2, is like Microsoft SQL Server. SQL is the language that we use to query relational databases like those. See here, you learned something today. Anything else? It's very interesting here because the next several slides are going to be funny because they all are going to be like, there are 2 kinds of programming languages, there are 3 kinds of programming languages, and blah, blah, blah. And each slide's going to say different stuff. What I see here is we have all of the different types of one of those slides represented, except one type of language is completely absent here, which is going to be very interesting. Okay, so these are some examples of programming languages. There are 3 types of programming languages. By the way, Evan, did you wish me happy birthday?
No, I did it in person with the rest of the class. I'll type it when I get back.
What game did you buy after you traded in?
I got Counter-Strike Global Offensive.
Oh, you didn't even get another Xbox One game?
I got Call of Duty. I just got that off of the store there. There's nothing hope for it yet. I already beat Rise. You gave that to me.
I know, Rise is so good. I love just the arms falling off and bloody gore, and oh, so good.
I wanted that one. I haven't got it yet.
What's up?
I wanted that one. I haven't got it yet.
Best game ever. Easy. Like, not hard, but it's tons of fun.
All right.
I would execute people even when I didn't need to execute people.
You said you got 1,000.
I know.
Yeah.
I unlocked this achievement you're like not supposed to unlock.
Ah.
Just executing every. Oh, so good. Especially like the one like he just cuts off both arms and then takes the little short sword and shoves it right through the front of his throat. It's all slow-mo. That's the best part. How many of you have seen the movie 300? The gameplay of this game is like that movie. It's awesome. And I could play it. I suck at video games. So I'm good at like, I'm bad at twitchy games. I'm good at like World of Warcraft and stuff like that. But any sort of first-person shooter, I embarrass myself. All right, so 3 types of programming languages. We have machine language. We have low level. And we have high level. Machine language is zeros and ones. At the end of the day, our computers speak binary. Series of zeros and ones. That's the definition of digital logic. On or off. 0 or 1. Human beings would not function well if we had the little 2-key keyboard. We're just sitting there tapping out zeros and ones, zeros and ones, 0 and 1. If you've seen the show Futurama, one of the episodes has Bender doing a robot play, and they're all speaking zeros and ones. Remember that one? I hate all of you. I try to stay somewhat current. Nothing. Garbage. All right, so zeros and ones, computers love, but human beings not so much. Low-level language has a one-to-one relationship with the CPU. We'll talk about this in a minute. High-level language has a many-to-one relationship with the CPU. Okay, so what's the CPU? All of our computers have it. What is it?
Central processing unit.
Central processing unit. That's what it stands for. Now, what is it? Go ahead.
It's the unit of the computer that controls all the other hardware in like the inputs and outputs and processes data.
Okay. That was the one kind of important part.
Yeah.
So this guy processes data. What does it mean to process data? Okay. So a CPU accepts instructions and follows them, right? So if we take one of our kind of common CPU architectures, let's do like an Intel Core i7, something like that. So that's going to be one of our newer architectures. All of these are supersets of the original x86 Intel. That's why you can take some piece of software that ran 15 years ago on Windows, and it has a fighting chance of still running today. Example I always use is the game Double Dragon. Have you ever played that? When I was a kid, that was like the fun game in the arcade, as if arcades still exist, right? But I got Double Dragon for my 486 DX2 66 megahertz computer. No, actually, I had it for my 386 SX 25 megahertz computer. That's where we're going with this. And it was awesome. Like, oh my gosh, we have the arcade game in our living room. Well, then I got my 486DX 266 megahertz computer. We had to wait for the chip to get released. 66 megahertz. Blazing fast. Well, whoever wrote that Double Dragon game did a really, really crappy job. Because what they did is, to delay the time between like when different enemies came out and things like that, they used what are called busy wait loops. So they would put a loop in there that just ran 1,000 times. Something like that to create a time delay. Well, a loop running 1,000 times took far less time on a 66 megahertz computer than it did on a 25 megahertz, significantly older architecture computer. So these guys were in turbo. The game was unplayable, completely unplayable on that new machine. So can you imagine it on today's computers? You're running these, you know, quad-core 3.06 gigahertz Core i7s, which, I mean, you're dealing with 16 generations newer processor. So you can't even compare the megahertz rating or the gigahertz or the hertz rating. You can't even compare those. They no longer scale. I can't even imagine what that game would look like on today's computer, because it was unplayable on a 66 megahertz machine. But that would be a kind of an interesting, interesting old programming, bad programming example. So we're not going to do stuff like that. So anyways, the CPU accepts instructions and follows them. When you take a modern day architecture, even an architecture like x86, back what I was just talking about, the CPU has a list of magic tricks that it knows how to do. So what Intel does when they design a processor is supposed to be a generic problem solver. It is supposed to be able to solve a kind of a generic set of problems, general purpose problems, using a set of individualized instructions in a certain order. Just like human beings. We have hands, our hands can go like this. We can turn our wrists like this, and we can accomplish different things by utilizing all of our different moving parts to do stuff, right? Okay, in a certain order. Processors in the same way. So they've given CPUs a list of magic tricks that they know how to do, and then your programming language at some level gives it a set of things like do this, then this, then this, then this, then this. Boom, something magical just happened. Okay? So CPUs have a list of instructions that they understand. A low-level language produces, well, a low-level language is also a list of instructions. And each one of those instructions translates to exactly one magic trick on the CPU. That's what is meant by this one-to-one relationship. So every line of code, if you will, in a low-level language, an example of a low-level language would be assembly language. Every line of code translates to exactly one magic trick on the CPU. Okay? Now, an important thing to understand about the CPU is each of these magic tricks may take multiple CPU cycles to complete. So a CPU cycle, think of that as the minimal, if the CPU is like an engine that spins, one CPU cycle is the minimum amount of time, the minimal amount of work a CPU can do. Not all instructions on the CPU take one CPU cycle. In fact, very few of them take one CPU cycle. When something takes one CPU cycle, it is known to be atomic. I'll put that out here. It's kind of an important atomic can mean a couple of different things. It either takes exactly one CPU cycle, or it acts as if it took exactly one CPU cycle. What that means is nothing else could happen between the time it started and the time that it ended. Okay? But in any case, all the set of instructions that an Intel processor knows how to do, all of those guys aren't necessarily atomic. In fact, most of them are not. So some of them may take 10 cycles. Some of them might take 30 cycles, especially the input-output stuff. But the point is that each one of those instructions is thought to be kind of a minimalistic widget that when used in conjunction with other widgets can solve problems. Make sense? That's what a CPU is. It's a collection of magic tricks, as I usually refer to it. So a low-level language means we get to talk to the CPU on a magic trick by magic trick level, telling it very distinctly, succinctly. I don't think either of those words are correct. Whatever. Granularly telling, oh, that's a good one. Granularly. Telling the CPU exactly what to do, one step at a time. Okay? That's what a low-level language is. Human beings could pull this off significantly better than we could do the zeros and ones. We don't like low-level languages, but we could use low-level languages. And I'll talk about a scenario when we want to use a low-level language in a minute. Okay? High-level languages. Many-to-one relationship with the CPU, which means every line of code that we write in a high-level language translates into many magic tricks on the CPU. That's our cup of tea. We like power tools, right? Now, going back to our list here, Java, VB, C#, Python, C++, C, PHP, JavaScript, CSC, Ruby, Perl, HTML, SQL, all high-level languages. Every one of them is a high-level language. Okay? Now, why would we ever use a low-level language? Well, in order to answer that, we need to talk about how high-level languages are used. Okay, so to talk about high-level languages, there are two types of programming languages. Interpreted languages and compiled languages. Okay? Interpreted languages, we take the high-level code and in real time, during runtime, we follow those instructions. Do this, then this, then this, then this, then this. Okay? And all the processing is done during runtime. And we start interpreting it. Think of this kind of like a an interpreter at like a Congress or something like that. There's presidential talk where you didn't have the fake interpreter at the Mandela thing. Did you guys hear about that?
Yeah.
Guy was up there making just like zigzag noises and stuff. Zigzag. Saturday Night Live did a pretty funny spoof of it. But in any case, so you got this interpreter up there. He's hearing, let's just say, English in one ear, and then translating it into, either in that particular case, sign language. But you might be delivering it in Japanese or something like that. But that's happening in real time, right? So there's a delay. So the people who are in the audience who are waiting for it in Japanese are having to wait for the interpreter, hear it in English, do the translation, and spit it back out. Okay, so not great performance, but hopefully it's fairly accurate, right? That's what an interpreted language is. So the first thing we should think when we hear about a language being interpreted is that it probably is not a high-performance language. Now, high performance can mean many different things. Reason being is that our computers today are so fast that we may not be able to actually detect the difference between a program that is running slowly versus a program that's running quickly, because the computer is so quick, so fast. Okay, but if you really were to measure it in CPU cycles or something like that, an interpreted language would almost always be slower. Okay, now because they're doing the interpreting in real time during runtime, compiled languages, they go through a process called compilation. We compile these before runtime. So what does it mean to compile? Well, we have a tool called a compiler. A compiler translates a high-level language into a low-level language. That's the job of a compiler. And all of this is done prior to us actually running the program. So we're doing a lot of that heavy lifting ahead of time. So what we end up having is a list of low-level instructions that is instructions that have a one-to-one relationship with the magic tricks the CPU knows how to do. We have that before we actually start running our program. So the hope is that will be higher performance, quicker. Okay? So we should think of compiled languages as being high performance, interpreted languages as being lower performance. Now, we might say, well, why aren't all languages compiled? Well, compiler theory is difficult. I'm teaching our compilers class this semester. And it's not, well, I think it's fun. But most of the students don't think it's fun. That tool to actually compile the language is very, very, very complex. And since our computers are so fast, we might not actually benefit from having a language be compiled, right? Now, if we're dealing with a video game or something like that, absolutely, we want it. We don't care about the complexity. We want it fast, right? But if this is a business application or something like that, our computers are so fast, we're not going to tell the difference. Let's just make it work. Okay, so that's why interpreted languages do exist. And they actually are more and more commonplace today because of how fast computers are. There's a point where there's no difference in terms of how human beings perceive the performance. But a compiler translates a high-level language into a low-level language before runtime. All right, now, getting back to this, why would we ever want to handwrite code in a low-level language? Well, there's a decent reason. Let's go back to that argument of video games. Most of our video games today are going to be written in either C++, which is a little bit older high-level language, or possibly C#, some of the more recent ones, but probably still C++. Let's just leave it at that, unimportant in this example. C++ is a high-level language that is also a compiled language. Therefore, before we run our video game, before we double-click on the icon to launch it, that game has been compiled into a set of low-level instructions that the CPU knows how to interpret, knows how to translate. Okay? Now, the efficiency of those low-level instructions is only going to be as good as our compiler can put out. This guy's kind of an interpreter, right? We're feeding it lines of high-level programming language code. And it's doing the best it can to turn that into the most efficient, while still being accurate, low-level code. Now, there might be some situations, it's less and less common today because our compilers keep getting better and better and better, but there could be a situation where a very specific part of a video game might benefit from taking out some of the fluff the compiler created, or maybe doing the rewriting that portion of low-level instructions by hand to make it faster. You know, when we write a high-level program and we put all this error checking in or something like that, the compiler might put that in, that error checking is going to translate into the low-level language. Well, if we happen to know that this particular part of the video game needs to be very, very fast, and we also happen to know that errors will not happen here, hopefully, we might decide to streamline that part of those 100 instructions, those 100 low-level instructions, to take some of the extra checks out to speed it up. That makes sense? So that would be a case where a human being may get involved with writing some low-level code, but that's really becoming less and less common today. Almost not seen. But we go back 10 or 15 years, it was relatively common for our most complex games. But compilers are getting very, very good today. Kind of make sense? All right. All right, 2 types of programming languages, interpreted, compiled. There are 3 types, types of programming languages. We have functional, procedural, and object-oriented. I'm not going to spend very much time on functional languages. We almost have an entire course on functional languages. I teach a computer programming theory course, 470, I think it is, where we actually write our own computer language, our own computer programming language, using a functional language. But functional languages solve problems in terms of a set of functions, and that's a super weak definition. I'm just going to leave it. If any of you have a Texas Instruments graphing calculator, the language on there is a functional language. So just kind of know that functional languages exist, but without really showing you one, it would be hard to tell you much more. All right, procedural, object-oriented, these are the ones we really care about. Procedural languages, monolithic in nature, and very sequential. And I'm going to talk about those in more detail here in a second. Object-oriented solves problems in terms of objects, which is most similar to the way humans solve problems. Okay, now the best example I can give you for something like this, and then I'll stop because I want to tell you about your homework assignment. Let's say that we came in to class, and over here on this table, I have a telephone. Now, is it possible for me to have a giant pile of wires over here? At first glance, it just looks like a pile of wires, but that it actually is a telephone. Is that possible? It's possible that somebody took what we think of as a telephone, split it open, spread all the wires out, but didn't actually disconnect anything. And we actually have a telephone there that just looks like a pile of wires. That is a procedural version of a telephone, where all the details are exposed. It works, but you see all of the details. Okay? That's where the monolithic aspect of it comes in. Now, object-oriented languages, that same telephone would look like what we consider a telephone to be. It would be a telephone object. We know that inside the plastic casing is all the details, all the wires and that crap, they're all in there. But all that's actually exposed to us is the public interfaces, the buttons, the handset, the stuff that we actually need to use in order to utilize the phone. That makes sense? So object-oriented languages have all the details encapsulated inside of an object and then expose public interfaces for us to actually utilize the objects. If we need to get down into the nitty-gritty, we can crack open the phone and get in there and mess with wires. But most of the time, after we've originally created it, we're just dealing with objects in terms of their public interfaces. Procedural languages, we build all the details, just like we do in object-oriented, but we don't have a way of hiding them. So when we actually go to use it, we are having to fish through our wires to find those public interface equivalents to the object-oriented side. That make sense? Okay, so let me talk about our assignment here. So in Angel, under lessons, the syllabus is in there. I do have homework directions and self-assessment template. So make sure you read this. Every assignment, when you submit it, not only are you attaching a document, but I also want you to take these 4 lines, copy them, and paste it into the solution box for your assignment and answer those 4 questions. Okay? It gives me some additional information to give partial credit where you struggled or something like that. Okay? And that's required. If you don't do this, I'll just give you a 0 in the whole assignment. So don't forget that. It's on recording now. So every assignment you do, I don't care if it's programming or a paper, copy these 4 lines, these 4 questions, paste it in with your assignment, and answer them. Okay? Now, your first homework number 1, it's going to be due on, I think I made it due on Friday. Let me double check that. That's Friday, right? 31st? Mm-hmm. Okay. It is, write a 2 to 3 page paper which answers the following questions. What is a game engine? Why do we need them? And then pick a popular game engine and summarize its features and why someone should use that game engine. Okay? We're actually going to be using a game engine here in class. So we're going to, this is your pre-research to find out what kind of tool we're going to be using. Make sense? Questions, comments, concerns, bribes?
Do you have information on format?
I don't, it's write a paper. I don't need a bibliography or anything. Just no broken English. Yeah. Try to be a good writer, but I don't care about footnotes and things like that. Let your English professors deal with that. Okay?
Double space? I don't have one this semester.
Whatever.
Fair enough.